So hello everyone, welcome back to my channel. In this video, we will discuss about this problem of that's name is kth largest element in BST. Okay, so you have given a binary search tree, and your task is to complete the function which return the kth largest element without doing any modification in binary search tree. So you have to be return that kth largest element from the binary search tree. Okay, so you should know about solving this problem. So you should be aware about binary search tree. So I'm just little bit of understanding to you what is binary search tree. Just I am giving you some example. Like this is the root node is called 2. Okay, so their left element of this particular root node is less than to the root node. Okay, and their right side is always greater than the the root node. Okay, so I am giving you some another example. This is a 10. So so their right side is always greater than like 12, 13. No smaller element would be present into that right side. I hope it would be clear to you what I am trying to say. This is called a binary search tree. If you don't know, if you do not know about that what is binary search tree, so please go through and learn about that binary search tree. Okay, so I am just forwarding this question like so. You have a given example like 4, 2, and 9. Okay, so their left side is always less than from the particular node. Okay, and their right side is always greater than of this particular node. Okay, so you have to find the second largest element in this binary search tree. In this binary search tree, so there are the second largest element is 4. Why? Because of that the first largest element is 9, and their second largest element is 4. I hope it would be clear to you. Now let us discuss about the second example. Second example is that 9 and 10. 9 and 10. So you have to be get that first largest element. First largest element. So their first largest element is 10. I hope it would be clear to you. It would be clear to you. So how you can solve it? Let us discuss about. Let us discuss about that trial. Okay. Let's try run this approach. So how you can solve it? So this is a root. This is a root node, and this is a left child, and this is a right child. Okay. Now what you will do? You will simply find the second largest element. Now what you will do? You will simply create a count node, which is counting for that your your node. It is equal to that second largest. Initialize with that 0. Okay. If if your so first of all, what you will do? You will go through that root right. Why? Because of that you know very well. You know very well that their right side is always present that maximum element. Is always present that maximum element according to that binary search tree. Okay, so firstly you will go through that particular so you will go through that largest function and go through root right. I hope it would be clear to you, and you will check that you will check that and you will check that and in first of all you will increment your count by 1. Why? Because of that, because of that, you will be you will be visited that first right node, first maximum element in this in this root in this binary search tree. Okay, in this binary search tree. Now, if it is if count is not equal to if count is not equal to kth largest element, if it is equal to, so what you will do, you will simply return your root data, your root element. I hope it you should know very well that what is that approach. If it is if it is not equal, then what you will do, you will simply move that their left side, move that their left side. So the largest function will be called and go through their left side. At the end, we will return simply root data. Okay, so now first of all, let's think that about example. Yeah, so this is a root node. First of all, what you will do, you will simply go through their right side, go through their right side. Now, and if you will go through the right side, so your count will be increasing by 1. Your count will be increasing by 1. Okay, so now, is 1 is equal to 2? No, the 1 does not equal to 2. So what you will do, you will simply visit that visit that. So so again we will increment the count by 2. So now again we will check that 2 is equal to 2. Yes, so this is our second largest element. Let us discuss about that another example. Like 9 is that root node, and their right side is always greater than according to the BST. Okay, so you have to find that first largest element. First largest element. So you have to be just check that, you have to be simply go through that their right side. So if it is if if count is equal to kth node, yes, kth node, because of that I will visit this node. So first of all, before this check, I will increment the count. So if this 1 is equal to 1, so I will return this value. Okay, now let us discuss about that another example. Like this is 3 is the root node, and 2 is the left node, 4 is the and 5 is that right node, 4 is root node, 1 is their node. Okay, so now how you can solve it? You have to find that third largest element. You have to find that fourth largest. Suppose of that. Suppose of that you have to find that fourth largest element. Okay. So now first of all go through that their uh, visited. So first of all you will go through that their right side, and again you will go through that their right side. Okay. So their right side does not present any node. It is null. It is null, so it will be returned to that -1. So this is our base case. If it is root is null, so I will return -1. Okay. So now I am just vision visit that first maximum node in this BST. So I will increment my count by 1. Okay, this is my count, and count will be increment by 1 to 0. Okay, now what you will do, you will check that is 1 equal to 4. Is 1 is equal to 4? No, 1 does not equal to 4. So what you will do, you will go through their left side. So again we will check that, again we will increment our count, increment our count, increment our so yeah, so I will simply increment my count by 2. Okay, so again we will check that if it is 2 is equal to 4. No, 2 does not equal to 4. Okay, so now again we will check that, again we will move that their node. So I will visit this node, so I will increment my count by 3. Because of that I will visit 3 node. I will visit 3 node, 1, 2 and 3. This is 1, this is 2, this is 3. I had visited the 3 node. Okay, so the I will check that is 3 equal to 4. No, 3 does not equal to 4. So this is not our correct answer. So I will simply move to that their left side. So this is when I was visited that their left node, and their right node is null. Right node is null. So I am just visiting this node, so I will increment my count by 1, which is 4. So 4 is equal to 4. Yes, 4 is equal to 4. So what you will do, you will simply return our root data, which is 2. So in this BST, in this binary search tree, the fourth largest element is 2. The fourth largest element is, I hope it will be clear to you, that is 2. Okay, so this is our answer. I hope it would be clear to you what would be that approach. Let us discuss about that coding implementation. So here is the code. I will simply call that C. C is nothing. This is a count. So count is equal to 0. Initialize with that, and answer I will get that answer. Because of that, if it is only present that only one element, which is 1. So at that time I will return only that particular answer. I hope it will be clear to you. So what you will do, you will simply check that if it is root is null or count is greater than k, means of that I would be find that fourth largest element. Fourth largest element. Okay, but you have to be present only two elements. So how you can check that? I don't have any fourth largest element in this given BST. So that's why to solve this test cases, so I will return -1. Okay. First of all, I will visit that root, right? Because why? Because of that, our maximum element will be found at root, right? Okay. Now again we will increment our count, and and if it is equal to the k, I will return root data. Otherwise, we will move that root left. Okay. Then we will return our answer. We will return our answer. So this code is working now perfectly. You can check that. Oh, my mistake. Yeah. So this is account. This is count, and this is okay. I hope it would be clear to you. So our output is equal to expected output. This is the solution of C++, and here is the solution of Java. Like, so first of all, no, there is a solution of Java. You can simply go through that and make that. Yeah. So this is our public end count is equal to 0, and first of all again you will get that public end answer is equal to 0. Okay, now you have to get that base case. What would they give you? The base case is that root is equal to null. Otherwise the count is greater than the k. We will return max. Otherwise what we will do, we will simply kth largest element, and go through that root, right? Okay, and increment that count by 1. If it is count is equal to that, simply return our answer will be updated by that root data. Oh, root data. Okay, so here is the mistake also. Otherwise you will simply go through that root left. If it is the left, if it is that a right side is not present, your correct answer. Okay, finally what you will do, you will simply return our answer. I hope it will be clear to you. Oh, my mistake, is there any? Yeah, so this is a simple solution. Yeah, so our output is also that expected output. I hope it will be clear to you. If you have any doubts, so please comment my channel, please like my video, please subscribe my channel. Thank you.